All right, everybody. Today we're introducing limits some more. And then tomorrow we'll talk about them algebraically. Today we're just going to talk more about what they are in general. And so if we've got a function f, which is defined for all x near a, except possibly at a, okay? If our function is arbitrarily close to some number L, and it can be as close as we like, for all x that's close but not equal to a, then we can write that the limit as x approaches a of this function f of x is equal to L. Okay. Now, most of the time we can think about the limit as the value of the function if it could be evaluated at that point. So here, we'll draw a picture so you can kind of see what I'm talking about. Okay, so let's say I've got some function that's looks like this. All right, so there's my function. Okay, we can see we've got a couple holes, a jump point. So let's look at this in terms of some specific values. Okay, so let's first talk about f of 1, or at x equals to 1. Okay, so f of x, or f of 1, if we plug 1 into our function, okay, that's going to equal 2. Because we're talking about our point here. And we can look at the limit as x approaches 1 of our function f of x is equal to what? And so when we're doing these limits, we're wanting to look at, okay, here's what x value I'm looking at. What is the function doing as it gets close to that value? Okay, and as the function's going along, it looks like at that point it's going to be 2. Okay, if our function is filled in at that point and evaluated, then great, that's what our limit's going to be. That won't always be the case. Sometimes it'll be the case like at x equals 2, where we have at x equals 2, we've got a nice hole here. It's filled in up here. Okay, so f of 2 is equal to 5. Okay, because that's where the actual point is. But the limit as x approaches 2. Okay, as our function is approaching where x is equal to 2, where does it look like the function is going to be? And it looks like it's going to be 3. Okay, so like if you could not see, let's say if you couldn't see this point up here, and all you had was this function down here, where would it look like the function was going to go? That's our limit. Okay. And so in this case, we had the value filled in at another point. But in the last case we'll look at is, let's say we've got a function, let's look at x equal to 4 or 3. Let's say 3. Okay, so at x equals to 3. Okay, f of 3 does not exist. There's a hole there. There is no value filled in anywhere. But where does it look like it's going to go? So if we look at the limit as x approaches 3 of f of x, where does it look like the function should be? Or what does it look like that value should be? And it looks like it should be 4. Okay, so in general, that's what the limit is doing. We're looking at where the function if the function was like a perfect function, okay, and it didn't have any holes or it didn't have any jumps, where would it be? Or what would that value be, okay? So that's kind of a limit in general. We can break it up into right-sided limits and left-sided limits. And so a right-sided limit is that, say we've got some function, f, defined for all x near a point A, okay, and we want x to be greater than A. Okay, so we're looking for all the values of x. So let's say 3 was our x value. We're looking at all the x values for x greater than 3. So we're looking at all the x values on the right side of 3. Okay, so we can write the limit as x approaches a plus. So that little plus just means that we're coming from the right side and we're looking at all the values greater than a, whatever that a is. Okay, and we say that the limit of f of x as x approaches a from the right equals L, or whatever value. We can have the same for the left-hand side. We're just looking for, we'll use 3 again. If we're looking at a left-sided limit, we are looking at all the values less than whatever value we're using. So in this case, we're looking for all the values less than 3. Okay, and we write this with a little a to the minus symbol, okay? Now, if our two-sided limits equal, so let's say we've got right-sided limit and that's equal to L, and our left-sided limit's equal to L as well. So they're equal to the same number. They're equal to each other. If that's the case, then our limit itself is equal to that number. Okay, if they're not, then that limit doesn't exist. Okay, so let's do an example. Okay, so let's say I've got a graph here. Okay, there's my function. Get a graph of it. So I want to look at the right-sided limit and the left-sided limit. So we're looking at the limit as x approaches 3 from the left. We'll do that first, of our function f of x. So we're looking at x approaches 3 from the left. So we're looking at all of these values when x is less than 3. Okay, so what is our function doing when we are coming from the left? Well, it's getting and approaching 4. Okay, and we can do the same if we've got the limit as x approaches 3 from the right of f of x. Okay, so we want all the values as x is greater than 3. So as those values that x is greater than 3 get close to 3, what does our function look like it's going towards? And it again looks like it's going towards 4. And so then because these two are equal, then our limit as x approaches 3 of f of x is equal to 4. Okay, now this won't always be the case. So sometimes we might have something that looks like something that looks like that. So let's say we've got that function. Okay, so we want to look at the limit as x approaches 2 from the left. So less than 2. As x approaches 2 from the left, where does it look like the function's going to go? It looks like the function's going to go to 1. Okay, and then we can look at it as x approaches 2 from the right. Okay, from the right, we're looking at all the numbers greater than 2. So greater than 2, where does it look like it's going towards? Well, it looks like it's going towards 4. Okay, these don't equal, so that means our limit as x approaches 2 of f of x does not exist. Okay, and you don't write an equal sign. You just say that it doesn't exist because it can't equal, does not exist. Okay, so kind of a note. No equals when does not exist. Okay, but so that's our general idea with limits. Okay, and that's how our right-sided limits and our left-sided limits are equal to each other, or how they're related. All right, so tomorrow, and so the video for Wednesday and Thursday this week, we'll do more about the algebraic techniques. So if we're given a function, not just the graph, but the actual function, how can we evaluate the limit? Okay, so that's what we'll talk about then.